Alright, so we're going to talk about this example here. We've got the velocity function. We get a ball given by vt equals negative 4.9t plus 25. The reason I've chosen velocity is because it allows us to go both up and down the ladder. So the first one we need to determine the acceleration of the ball. Now remember that acceleration is equal to our derivative of our velocity function. So all we need to do is to derive our velocity. So that's our velocity function. Derive that. That goes away. We get rid of the t. It now becomes negative 4.9. What does that tell us about the velocity of this ball? Sorry, the acceleration of this ball. It's decelerating or going down. We define that as negative. Is it changing over time? Our acceleration is constantly negative 4.9. Sure? Doesn't change over time. That's question A done. Straight up. The only variation of that is I might say if there was a t, I might say determine when the acceleration is this, or determine what the acceleration is when time is 5 or 6 or whatever. Cool? Makes sense? If it says the word initial or starting or origin, what does that mean?
0.
Yeah, let time equals 0. Determine the position of the ball, xt, given that the star is 2 meters above the ground. So the first thing we're going to look at is obviously just determining what xt is, and then we'll look at the rest of that information. Because we're determining position, we start with velocity, we're going up the ladder, we need to integrate. So xt equals the integration of our velocity with respect to time. Notice it's not dx, it's dt, because that's the variable we're changing. Xt equals the integral of our velocity function. We then integrate that. All good with that. Plus c. This is where I'm dealing with the given that we start 2 meters above the ground. So when I say given that we start, what I mean, let t equal 0, and I know that my position equals 2. So 2 equals, which means that that equals 0, that equals 0, c equals 2. Shove that in my equation. That's my position function. Cool? They might say determine the time when the ball hits the ground. How do I do that? Let xt equal 0 and solve for t. How many solutions would you expect? 2, because it's a quadratic, correct? Negative quadratic. What's one of them going to be?
0.
Think about how this looks, right? We know that when time equals 0, it equals 2. So it's going to go. It's going to go negative one of the times, correct?
Yeah.
Before it hits, so that one's not going to work, giving you only one solution. That's the sort of questions I can ask in kinematics.
Wait, why is one of them work?
Because this is going to be a few sketches function, right? I need a. If you sketch that function, that's fine, no. I wasn't happy with the explanation. If you sketch that function, it's going to look something like this, right?
Yeah.
It's going to have 2 points where it equals 0. This point here and this point here. But that point doesn't work because what's our x-axis here? It's not x, it's time, and time can't be negative. Cool? All good. Keep going.
Wait, so is that, did you get t next to the 25 like you showed that you yesterday? That's like
Yeah.
Okay.
Same thing.